Hi everyone. NET226 scaling networks. Okay, so 9.1.15. These are some of the things we discussed in the first class. When your first term here, you learned all about networks. They call it Introduction to Networks. And the second class is a large amount of information that you learned. You learned about switching, and in there a lot of work with VLANs and so forth, and then you learned basic routing. We talked about OSPF routing in a single area, and routing in general. You learn about routing protocols and so forth. The next thing we move to is how do we scale a network, and they talk about enterprise systems. So what we did is we first started talking about all the things that run on a network. You know, the phone system, the if you're going to exchange videos and audio files, and then basic data. You know, the thing most people think of when they think about exchanging information on a network. I gave an example of Newman Elementary. When they built the new one, they split a few of those things, and they had an intercom that was separate. The fire system was separate. Some schools early on, not that long ago, had a separate coaxial cable network, for running all their video. The high school at Newman was that way for a while. They had coax to each room. They had a separate wire for phone to each room, and then I think they had maybe a couple data wires to each room. So what has happened is a lot of this is converged into the network. So once it's in the network, it's very important because some data that's going through is much more critical than maybe another piece of data. And some would need more bandwidth if you're running a video through compared to otherwise. So they used to separate this, but it's really converged in networks nowadays. So what we're concerned about is performance. We talked about today, we talked about the items that would affect that. We talked about bandwidth. It's going to affect that. How much traffic you have at a certain time of day. If you're going from network to network, how many hops. If you're running through VLANs, or you're running, you have different networks. Obviously, is your building have Cat 6 wires? Does it still have some old Cat 5? Do you have some fiber involved between buildings and so forth? The medium, lots of things that we think of when we talk about performance. But really, what people want, you might call it speed, or a lot of times response time. When they click, how fast is it that they get what they want to get? Sometimes you can handle that internally, sometimes that's affected more broadly in your connection to the internet. And then how reliable is the network? Really, a couple different things, This is talking about response time. This is talking about, is the network there? Is the network used enough? If the response time is extremely slow, somebody say, well, it's not very reliable. But reliability. So we can build redundancy in the network. There's a cost to that, okay, for equipment and to maintain it. So we talked about this key thing, performance. Also, which is important, performance is when your network needs to expand. How can we do that? We're going to talk a little bit about that. So we started out in class and we talked about users. Okay, how do users access a network? So we have the access layer. They may access it through an access point from a device. They may have a cable right into a switch. Most common ways to access the network. Okay, through the air or through some switching device. Okay, and then we can control things at the access layer. The next step then is how do we distribute the information once it comes into the network. A lot of times we want to access servers. You might want to access other people on the network, maybe. Or we might want to send information out to another location. So we have what most networks are, a hierarchical design. Huge how we can do that. So distribution, and you might have some access control list here to control what information goes where. Maybe some servers can only be accessed by certain people. Okay? Then we move to the core. We used the example, here's Mason City, here's San Francisco, here's Seattle, and here's Denver. And so these are all linked together somehow through some WAN connections. And so in our business, this would be, in this example, this would be the core layer. Okay? The connection between all those locations. And then when you think about it, the Denver location, what would it look like, or let's say San Francisco, what would it look internally in San Francisco? Well, if it was all one company, their internal would look maybe just like it does in Mason City. Maybe just a little bigger. Okay? So you get that consistency, and then if you add a location, okay, we add a location, hook this, maybe this location's in Rudd, but Rudd, when you farm that out and build it, you can build it similar to this. So you have consistency, you have the hierarchy, and then when you want to maintain it, it's very similar. You can better manage the entire network. And then you can scale it. You can bring it up and bring it down in size. For example, if this network needed to have a whole bunch of access points for a conference, you could add, you know, another 25 or 30 access points in the gym area or the conference area, use them for the big conference, and then redistribute them and use them other places. You could grow, and then you could shrink. You could scale. Okay? You could scale. Some terms we talked about: in-band, out-of-band. A lot of management can be done out-of-band. First example, or one example we gave, when you connect a console cable to a device to manage the device, maybe update the access list, that would be out-of-band. Okay? That would be an example of out-of-band. In-band is when you connect to the equipment through the same production network. So for example, you have a PC connected here, it's right on the main network, and you connect in to update some access points, or access control lists. Okay? That would be in-band. Nowadays with VLANs, in a lot of cases, if your network is set up with VLANs, you'll have a VLAN just for management. Get it? Port density, number of ports on the device. If the device is modular, you can add, take out. If it's not modular, that's what you have for port density. Forwarding rates, we use an example for like firewalls. I know some schools had firewalls. They were set certain limit on forwarding. They upped their bandwidth, so they got more bandwidth from their provider, but they didn't notice the performance increase. Should have been more. Should have been a lot more. So the issue was in their firewall. So they had to upgrade the firewall. All right. So, in summary, the whole idea is taking a look at, can we scale? Can we scale up and down based on our network? Another simple example. Increased bandwidth. We will learn that we can put multiple cables to connect two devices and make it look like one trunk. So we can expand bandwidth between two devices without, you know, using up some ports, but without having to add any ports and without having to change the type of ports. And that's some of the things we'll learn in the course, along with a lot about redundancy and so forth. So there's a quick overview of chapter 1 in the curriculum, and a start to the course.